year, Samsung introduced the Exynos brand of application processor. Our first Exynos product, the Exynos 4 Quad, proved to be a hit with the industry. Incorporating the 4 cores of the most advanced processor available, the Exynos 4 Quad offered unprecedented levels of PC-like performance, allowing tablet and smartphone users to perform several tasks at once without compromising speed, all while they enjoyed seamless graphics performance. Many of you have likely seen these benefits for yourselves. In less than a year, Samsung's Exynos 4 Quad application processors have been sold in more than 53 million devices. And last year, we added Exynos 5 Dual into our Exynos lineup. It's the processor behind that Chromebook and this Nexus 10 by Google. You see, Google had lots of options in processor selection. But in order to stand out in the mobile device market, they needed to use the best performing application processor, a processor that could support the best display resolution WQXGA. Our Exynos 5 Dual, based on ARM's top-of-the-line processor, is the only solution powerful enough to support that level of display resolution. So the choice was simple, and users could see the difference. E-books, photos, and even full HD playback became more lifelike than ever. Now, we are inspired to do even more, even better. The question that keeps me up at night is, how can we increase processing power while decreasing energy consumption? Well, I can report I have been sleeping pretty well lately because we have leveraged the benefits of Exynos 4 Quad and Exynos 5 Dual to create the next breakthrough for our Exynos lineup, the Exynos 5 Octa. The Exynos 5 Octa introduces a whole new concept in processing architecture. An architecture that includes 2 sets of 4 cores each. An architecture that gives you all the power you want to run intensive applications, but is smart enough to conserve energy when running more basic tasks. Ultimately, we are saving energy and prolonging battery life. So, let's see what the processing power of Exynos 5 Octa will allow devices to do. We built this reference device incorporating Exynos 5 Octa for this year's CES. This device is intended to show the amazing possibility the Exynos 5 Octa offers. One key difference is the level of pure processing power never seen before in a mobile device. Not just for individual applications, but for heavy-duty multitasking as well. Say, I wanted to do a quick web search for a good dinner spot tonight. I could load that page. I could simultaneously download an app to make a reservation, and retrieve GPS and mapping information, all without a lag or disruption of any of the applications. The Exynos 5 Octa. Perhaps the most powerful multimedia performance can be seen in 3D games. The Exynos 5 Octa provides 3D performance that is twice as good as any previous generation processors, including the Exynos 4 Quad. Here to demonstrate that 3D performance, is VP, the head of the mobile platform at EA, Glenn Rowland.
Thank you, Dr. Wu. Good morning. The first thing I want you to appreciate about the new Exynos 5 is a level of pure processing power never seen before in a mobile device. And this is not just for individual applications. It's also for heavy multitasking. It's also not just down to the speed of the processor. This capability is going to become more critical in the future as mobile applications with 3D gaming image processing become available. Let's see the Exynos 5 in action on my Samsung reference device. So the collaboration between Samsung and EA enables optimizations that enhance both the Exynos 5 and Need for Speed Most Wanted. And this results in several benefits. Smoother frame rates, which are important to a fantastic experience in gaming, where timing and proper controls are essential for competitive gameplay. High poly models and extra detail go into every car. Over-the-top collision mechanics allowing players to accrue more detailed damage to cars than ever before. This means every smash into walls, competitor cars, or pursuant cops creates an adrenaline-pumping frenzy of shattered windows, cracked headlights, and flying parts. Real-time reflections on the car immerse gamers in the fantasy locations of the Need for Speed Most Wanted world. Advanced paint shaders improve the look of the light hitting the car, helping bridge that gap to real-world action. Stunning graphics let racers see the world flashing by and gives the fastest sense ever in a Need for Speed mobile title. Beautiful radio motion blur effect takes console techniques for the first time ever and brings them to a mobile device. EA continually strives to bring high-quality, diverse, and graphically impressive games to our consumers. We work closely with our partners to improve upon the experience fans have come to expect from EA as these new technologies become available. Thank you, and enjoy CES.
Thank you for joining with us. Thank you. So, what we saw there was a completely new level of processing performance from a mobile device. Now, computing power is important, but in mobile devices, battery life is an equally important factor. The Exynos 5 Octa's architecture offers up to 70% energy savings, prolonging the life of your battery. What helps make this possible is our advanced silicon technology. Over the last 5 years, Samsung has continued to shrink the process nodes of our silicon technologies all the way from 90 nanometer to 28 nanometer in 5 generations. Each time we shrink the node, we gain speed and we improve energy efficiency. In the coming years, we plan to shrink even further, 20 nanometer, 14, and even 10 nanometer. We are talking about a signal line that is 5,000 times thinner than a single strand of human hair. At Samsung, we will continue to lead the industry with advanced silicon technology. But that's only half the story. For many years, Samsung has been working in close collaboration with ARM to set the standard for low-power mobile architecture. This year, that collaboration has produced a revolutionary new processing architecture called Big Little. Here to tell us more is my friend and colleague, the CEO of ARM, Warren East. Hi, Warren, welcome. It's great to have you here today.
Thank you. Hi, Stephen. Well, we're very excited to be here to share this next evolution of our partnership, the new Exynos 5 Octa.
Together, we have been relentless about challenging the status quo. We have worked together to create CPU solutions and application processors offering more and more computing power with less and less energy consumed.
Yeah. To me, Stephen, it's all about efficiency. While legacy processors focused on increasing performance at all costs, we have chosen to meet the needs of consumers in the mobile world. And that requires providing the right amount of performance at the lowest possible power consumption. And as we both know, you can't rely on incremental improvements in manufacturing processes alone if we're to enable the rapid evolution of mobile devices. No, we must look for new ways to accelerate progress. And that's why we created a new processor technology last year. Stephen, you talked about it a moment ago. We're very proud of it. It's called Big Little. Now, if we look back inside the reference device, we can see that the Exynos 5 Octa employs our Big Little processor technology. Each processor is designed for different types of workloads, and they work together in concert to provide optimal efficiency. There's a cluster of big processors, the 4 ARM Cortex-A15 processor cores, and they're designed for high-performance workloads. And then there's a cluster of little processors, 4 ARM Cortex-A7 processor cores. And they're designed to handle the majority of mobile workloads, and they're optimized for the lowest possible energy consumption.
Let's remind ourselves of the huge difference Big Little makes. I'm going to demonstrate the balance of computing power and efficiency. The bars on the left of the screen shows the workload of every processor in the Exynos 5 Octa. As you can see, for basic applications like that light web search and mapping we saw earlier, we are using the little processors. Then for more heavy-duty applications like that graphics-rich gaming and HD streaming, we switch over to the big processors. Matching the right processor to the right job and using only the energy needed for the task at hand.
Yes, this approach is really going to improve the user experience. It's providing roughly twice the performance of today's leading-edge smartphones at half the power consumption when running common workloads.
Really the best of both worlds. So Warren, what's next for Samsung and ARM?
Well, Samsung and ARM are both committed to bringing outstanding experiences to consumers. And as partners together, we will continue to drive innovations to enable better lives. At ARM, that means we will continue to drive efficient, low-power processing platforms offering more performance at less and less power. And that enables our partners to build market-leading system-on-chip solutions, not only for mobile, but for a broad range of applications from the home into the enterprise space. For example, we have added general-purpose compute capability to our Mali graphics technology, and that is to enable seamless interaction with the Big Little concept. And this further extends the ability of the system to use all the available processing units at just the right time for the most appropriate task. And that, of course, results in greater system-level efficiencies, and that frees up the main CPUs to further run other activities. Our Mali graphics CPUs are enabled with full-profile GPU compute, and that opens up new opportunities for new applications coming to mobile, as well as making existing use cases more efficient so they can be more widely deployed. A good example of that would be facial recognition. And it also enables new use cases altogether, such as multi-viewing of 3D content, so that different individuals can all get the same experience independent of where they're sitting relative to a DTV, for example. Now, driving this efficiency for CPU technology, for us, that means continuing our processor roadmap with efficient 64-bit processing, continuing to work closely with our ecosystem to ensure that at each stage of the design, we're absolutely focused on energy efficiency.
All amazing possibilities. And I'm confident that Samsung and ARM will be the first to make that a reality. Warren, Thank you for your partnership and inspiration, and thank you for joining us today.
Thank you, Steve.